Today's lesson will review adding fractions, and it will cover combining positive and negative fractions with addition and subtraction. So please update your table of contents. We are going to go to the vocab on page 45 and finish the next two vocab words that we didn't finish on the previous lesson. So please go there. So for the integers vocab, the definition is positive and negative whole numbers and zero. Some examples are negative 19, 30, 0, and negative 2, compared to the non-examples of 1/2, negative 5.8, and 9.7. So decimals and fractions are not integers, but whole numbers with a negative or that are positive are integers. So therefore, yes, if it has a positive or a negative sign, that's good, but it is not or no as an integer if there are fractions or decimals. Then this Venn diagram here is not a math Venn diagram, but it's to help you understand the next slide. So for example, if the whole category is dogs, inside of that category could be a Chihuahua. So a Chihuahua is a type of dog, but not all dogs are Chihuahuas. So once again, this is the large category, and a Chihuahua is a subset or a part of that category. So the math part here is the word rational numbers versus integers. So all integers are rational numbers, but not all rational numbers are integers. So for example, these numbers are integers, and those numbers are also called rational numbers, versus these numbers on the outside are not integers, but they are rational numbers. So the next vocab word is rational numbers. The definition is a number that can be made by dividing two integers. Therefore, it's a number that can be written as a fraction. In class, we go over these and I write these in. Negative 50 is equal to negative 50 over 1. 0.3 repeating is equal to 1/3. So you need to write 1/3 on your note sheet. And negative 4.5, which is the same as negative 4.5, can be written as an improper fraction, and that's negative 9 over 2. So negative 4.5 is equal to negative 9/2. Under the non-example, you have anything that's considered an irrational number, such as pi, or a number that goes on forever that doesn't repeat. And the characteristic is rational numbers are all integers and fractions, and all terminating in repeating decimals. So all of those types of numbers are considered rational numbers. So yesterday's lesson we did decimals. Today we're going to do fractions. And here's just a little fraction humor. So just to talk about common mistake. Common mistake is just adding across 1 plus 1 is 2 and 4 plus 4 is 8. And if you simplify that, you're going to get 1/4. So if you make the common mistake with a problem like this, hopefully right away you're going to notice it's super unreasonable. There's no way to add 1/4 plus itself and get only the number itself. It would be like saying 3 plus 3 is 3, which does not make sense because if you have 3 plus something else, it's going to get larger as long as it's not a negative value. So reasonableness. So the right way to do this is you add the numerators and you keep the denominator the same. So now if you simplify it, you will get 1/2. And 1/4 of something plus 1/4 of that item is going to be half. So if you took this square and filled it in up here, that would be half of the rectangle. So same thing here. We add the numerators, leave the denominator the same. Because if we have 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8, we would have 3 pieces and 2 pieces shaded in, and that's a total of 5 pieces out of 8. So 5 are shaded in out of the total of 8 pieces. I'm going to go ahead and skip this in the video. I kind of skip it in class too because it's enough examples before we can get to the note sheet. So looking at the note sheet on adding fraction review, In class, we highlight the facts. So the fact that the denominators must be the same in order to add fractions. And second fact, add the numerators and the denominator stays the same. So 3 plus 2 is 5. And in class, we highlight the 11s. Fact 3 is that if the denominators aren't the same, you have to find a common denominator. So we're looking at the denominators of 9 and 6. So the multiples of 6 are all these, up to 36 that is, and the multiples of 9 are these. So if we look at the last number, 36 is a common multiple of 9 and 6. So to go from 2/9 to 36, 9 times 4 is 36. Therefore, we're going to multiply by 4 over 4 because this is just a giant 1. 4 divided by 4 is just 1. So therefore, we're not changing the value. We're just changing what the fraction looks like. So 9 times 4 is 36. Therefore, we have to do 2 times 4 to keep it equivalent, and we get 8. And then on the right side, 6 times 6 is 36. So we're looking at what happened to the denominator. Whatever we did to the denominator, we need to do the same to the numerator. So 5 times 6 is 30. Then we add our numerators, which will be 38. Simplify the fraction, and you'll get 19 over 18. So back to our list of multiples, if we look, there is a smaller number that these two numbers have in common. So 18 is the lowest common denominator. So to change 9 into 18, we multiply by 2, and then 2 times 2 is 4. Over on the right side, 6 times 3 is 18, and 5 times 3 is 15. And then we would add the numerators, and we'll still get 19/18. So we just don't have to simplify it because 4 plus 15 is 19. And then final answer would be changing this to a mixed number, which is 1 and 1/18. So that's the review, because technically that is a 5th grade type of problem. So now we're going to do the 7th grade level of this type of problem. So for example 1, you're going to have -3/10 plus -3/4. The common denominator for 10 and 4 is 20, because 10 times 2 is 20, and 4 times 5 is 20. So 10 times 2 is 20. 3 times 2 will give us a 6 in the numerator. On this side, 4 times 5 is 20, because we always look at how did the denominator change. And then therefore we do the same thing to the top. So 3 times 5 is 15. And these are negatives, 7th grade level problems. So we have to remember to bring our signs down. Both are negative, so we're going to add them together. -6 plus -15 would be -21. And we change that to a mixed number, -1 and 1/20. For example 2, the missing number in the denominator is a 5. I recommend you pause the video and just take a moment to think about what the common denominator would be. So on this one, we do have to multiply 5 times 11 to get the common denominator. I also am changing my double negative into positives, because the opposite of a negative is a positive. So we're going to have 55 as the common denominator. Well, 11 times 5 is 55. So 8 times 5 is 40, and it's a negative. And then on the right side, 5 times 11 is 55. So 4 times 11 is 44, and this one's a positive. And because they are different signs, we are going to subtract. So 44 minus 40 is +4 over 55. This is still example 2, so now we're on to example 3. The missing numbers are 1/8. Pause the video and try the problem, please, before you see the answer. So what can be helpful is thinking of the multiples of the larger number to see if the smaller number can multiply to it. So for example, 12 times 1 is 12. 12 times 2 is 24. And if you know your multiples, 8 times 3 is 24. So the lowest common denominator is 24. Well, to change 12 into 24, we multiply by 2. So 11 times 2 will give us 22, and it's a negative. And then 8 times 3 is 24. Therefore, 1 times 3 is 3, and it is a negative. So we have negative 22 minus 3. They're both negative, meaning we're going to add them. So we get negative 25 over 24. And then you would change that to a mixed number, negative 1 and 1/24. Example 3 is still there, and example 4 has the missing value of 18 filled in. So please pause the video and try this problem before you see the answer. For this one, the LCM, or the lowest common multiple, is 18. So on the left side, we're multiplying by 2. And on the right side, it stays the same. So technically, we're multiplying by 1, or it just stays the same. And that's a negative, and the first one is a positive. So now we're just doing 14 minus 5, which is 9. But we do need to simplify it. So we will get 1/2. And that is the end of the notes and the lesson for today.